Okay, so I've drawn a book on a ramp here, and I'm going to draw in arbitrarily what the magnitude for the force of gravity is. So if that's the magnitude of the force of gravity, which of course is always pointed straight downward, I know that there must be an equal and opposite force that counteracts the gravity, which is why the book isn't moving up or down. Now, of course, there's really no force directed upward there. The only two forces are going to be friction, which is directed parallel to the surface, and support, which is directed perpendicular to the surface. So I know that there is a vector of friction that points sort of upward and to the right, because the book is tending to slide this direction. Friction always goes in the opposite direction. Parallel, and again, the support force, or the normal, is always perpendicular to the surface. So I need to figure out how long these vectors are to add up to this resultant, which would cancel out the gravity. Well, I've already got two sides of a parallelogram drawn here, so I'm going to draw the other two sides, trying to make sure that those are parallel, and parallel with that. All right, so I have a parallelogram, and I know that this side is going to be the force of friction, and the support force is perpendicular, or that's the normal rather. So I know that these two vectors would add up to this one, and that one is equal and opposite to the gravity. So these are the actual three forces that exist: gravity, friction, and normal. But notice that the normal and the friction add up to an upward directed vector, which cancels out the gravity. So everything here adds up to 0. The book does not move.